Hello, everybody. Today I'm going to introduce an AP Chemistry free response problem that we can kind of go through, and a problem that can very well appear on an AP Chemistry test that people take. We'll walk through it, we'll figure out interesting tips and tricks to solve it, and we'll work on the solution together. All right, so let's start. A student reacts 0.3 grams of methyl salicylate with a stoichiometric amount of a strong base. This product is then acidified to produce salicylic acid crystals. For every mole of methyl salicylate with the molar mass given, 1 mole of salicylic acid crystals with the molar mass also given is produced. Calculate the maximum mass in grams of the salicylic acid crystals that can be produced in this reaction. So notice how the problem gave you the molar mass of the C8H8O3, the methyl salicylate, and they also gave you the molar mass of the salicylic acid. And they also gave you the mass of methyl salicylate used, and they kind of gave you the mole ratio, which is 1 mole of C8H8O3 to 1 mole of salicylic acid. All right, the only thing we need to figure out now is the grams of salicylic acid that we can produce. So to do that, we kind of set this up. We have 0.300, so 300 milligrams of C8H8O3, and we're going to multiply by what we call a conversion factor. The conversion factor is going to be our grams per mole. They gave us our molar mass. So if we want to calculate how many moles we have, in this case, we want to divide by the molar mass. So we would write 0.3 grams of C8H8O3 times 1 mole of C8H8O3. And we divide that by 152.15 grams of C8H8O3. Once we do that, the grams of C8H8O3 cancel out, and we're now in the dimension of moles of C8H8O3. We can use the information highlighted in red, which is our mole ratio. For every mole of methyl salicylate we consume, we get 1 mole of salicylic acid. So our mole ratio would be 1 mole of HC7H5O3 divided by 1 mole of C8H8O3. And notice how the moles of C8H8O3 also cancel themselves out. All right, we can keep going. To figure out the grams of HC7H5O3, we multiply by the molar mass, which is 138.12 grams per mole. So we would multiply by 138.12 grams of HC7H5O3 over 1 mole of HC7H5O3. So we get that. So once we do that, the moles of HC7H5O3 cancel out, and now we're in the grams dimension. Great. So all we have to do is now plug this into our calculator, and we'll be able to figure this out. So let's do it. 0.3 divided by 152.15 times 1, then multiply that by 138.12, and that gives us 0.272 grams of HC7H5O3. And that would be your answer. Why would I round it to this much? Because notice how we have 3 significant figures over here for 0.3 grams, 0.300 grams, that's 3 sig figs, meaning our final answer has to have 3 sig figs, especially because all the other numbers given have 5 sig figs. We keep the lowest, so this is how you would write your final answer. All right, so that's pretty much the end of this question. Please let me know if you have any questions. Thanks a ton and have a great day.